Okay, so today the question we want to address is something that Egan brought up for us earlier this term. And that question is, why do two negative numbers multiply to give us a positive result? So again, why do two negative numbers multiply to give us a positive result? And today I want to address this question with more than just the whoop that Egan so elegantly demonstrated for us. So how I want to do that is look at just an example and then expand that to the general case. So we all know that when we take two positive numbers and multiply them together, we're going to get a positive result. I think that's pretty clear for all of us here. For example, 3 times 5, we got 3 groups of 5 that should give us 15. But what we want to do is start to introduce these negatives here. And so as an example, I'm going to use these two numbers just for simplicity's sake. And I'm going to take 3 and I'm going to take negative 5. And we want to show that the product of these two numbers are going to give us a negative result. And to do that, I'm going to look at this here. I am going to look at 3 multiplied by negative 5 plus 5. Now, it's pretty clear that negative 5 plus 5 is 0. And we all know that 0 multiplied by anything is 0. Now, if that's the case, then this expression here, 3 multiplied by negative 5 plus 5, must equal 0 as well. And once we get to this point, we see from the distributive property that I can take this 3 and multiply it into the bracket. And watch what happens. If I take 3 times negative 5 and I add 3 times positive 5, I'm still saying that has to equal 0 because of the equation that we had set up. Now, as we showed up here, it's pretty obvious. 3 times 5, that's 15. Well, if I need to get to 0, what does this result have to be? It's got to be negative 15, right? Well, what does that say? That's telling us that these two numbers, a positive and a negative, are giving us a negative result. All right, so here we got, right, 1 positive multiplied by 1 negative give us a negative result. And we're going to use this to continue to answer our question at the start. So we've got that established. Let's move on. Now we want to look at 2 negative numbers. Okay, so let's look at negative 3 and negative 5. 2 negative numbers. We want to show that these two give a positive result. So we want to see that these equal positive 15 in the end. By the same sort of logic that we just worked out above, we get, I'm going to use this, negative 3 times negative 5 plus 5. That should equal 0, right? Because negative 3, those two equal 0, will give us 0. So, using this, I'm going to follow the same logic as above, using the distributive property. And watch what happens. The negative 3 distributed with the negative 5 is going to be summed up with the negative 3 multiplied by, positive 5. And what did we show in this case up above? Positive and a negative will give us a negative result. That's what we're seeing here. And that should give us negative 15. Now, because we have to equal 0, what does that say about this product? These two negative numbers must be positive 15 to counteract the negative 15. And as we can see, what happened here? Two negatives gave a positive. And thus we see that the product of two negative numbers gives a positive result. Voila, there you have it. Now, just to extend this case for those who are saying, oh, well, you only used two numbers, that doesn't prove the case for all cases, we could just have easily replaced the 5 and the 3 with these arbitrary numbers a and b, where we see a and b both being greater than 0. And then we could follow the exact same logic where we take one of them to be positive, one of them to be negative, and we will find out that this equals negative AB. And then we could extend that to the second case and take two negative numbers following the same logic as the previous page. That should give us positive AB in the end. So for those of you who are wanting to look at the general case, you could follow the same logic and you will see that these two equalities will hold. Thank you very much.